When the exponent is a fraction, so such as this, we can simplify that. So we don't leave it like that. We can simplify it.
2.5.
Nope. When the exponent is a fraction, here's what happens. Ah.
Oh my Lord.
Hold on. That's not what I wanted. Okay, we can simplify. The denominator of your fraction becomes the index of the radical. And this is why vocab is important. The denominator of the fraction becomes the index of the radical. So our index would be what? 2.
Does that mean the top one becomes the power?
So then, so the numerator, I don't know if this goes on a new slide or not, so I might just wait for a second. Remains the exponent. So technically, we would simplify this to say the square root of 25 to the first power. So the numerator is the exponent that you're taking that radical to. And the denominator becomes the index of the radical. So this becomes the square root of 25 to the first power. If we were going to simplify this, the first thing we would simplify would be the radical. What's the square root of 25? 5. To the first power, which is 5. 5 to the first power is 5. Okay, let's simplify this. Negative 512, that's our base. And it is taken to a fractional exponent. Okay, what do we do with that 3? What does it become? The index of the radical. What is our radicand?
Negative 512.
Good. The base is the radicand. So underneath our root is that base negative 512.
And the exponent is what?
And the exponent is 1.
1 as in 1.
1 is in. Good. So to simplify, if you're asked to evaluate, to simplify, the cubed root of negative 512 is negative 8. Bless you. And we take that to the first power. So simplified, this is just negative 8. Let's look at this one. No, we're going to do a couple more to practice, and then I'll give you the homework.
Could you have, like, complex number? What's it called where there's a whole number?
An improper fraction? Yeah, you could. Yeah.
So,
You do the same thing.
well, then what would you do with the,
The numerator, it would just remain the exponent.
okay.
So like squared. Simplify this. Okay, what does the 3 in our denominator become? Okay. The index.
What's the square root of 63?
4.
Okay, our radicand is that base of negative 64, and we will be taking this quantity to the second power. That's our exponent. Let's start by simplifying. Within, what is the cube root of 64? Negative 4.
And that to the second becomes 16.
Good, and then we square. No, it's a positive because that negative 4 is in parentheses, so we're multiplying negative 4 times a negative 4, which is a positive 16. Try this, and we're going to do a few of these so that you're really comfortable with it by the time you leave, so that when you go to do your homework, you feel confident in this. What is this? Tell me what it turns into. Yeah, I'm going to have you go even more baby steps. The square root of 9, right? Because that 2 becomes the index to the 5th. And then, yes, the square root of 9 is 3 to the 5th power. 3 to 3 is 9, 27, 81 times 3.
125.
Is it 340? No, 243, 340. I don't. 243.
243.
It's 3 times 3 times 3 times 3. 3 is our
Oh,
base.
Right, you can't do it the other way.
Yeah. Okay, you with me so far?
Yeah.
Okay. Try this one. Okay, what does this turn into? With our radical, what would this look like? Malia.
The index would be 4 and 256 is the radical.
Very good. The 4th root of 256.
To the third power.
Very good. To the 3rd power. What's the 4th root of 256? Sometimes you have to guess and check with these 4th root. Is it 4?
Maybe like 5.
Yeah, it is 4.
Oh, no, it can't be 5.
It's 4.
It is 4 times 4.
The 4th root of 256 is 4. We know that because 4 times 4. So 4 times itself, 4 times, gives us 256. So then we take that to the exponent of 3. 4 cubed is what?
64.
Good. 64. Okay. Okay, you won't see this a ton today, but we will see this moving forward. Exponent rules and all of the exponent rules that we have gone over and that we reviewed a little bit last week apply
So what?
to negative exponents. So negative rational exponents or negative fractions. What's the first problem here?
It's 1. Oh, wait, it's a negative.
It's a negative exponent.
Negative.
This is the first problem. How do we get rid of a negative exponent? What would we do? You drop it, you move it across the fraction bar. Remember that?
Yeah. So that'd be the 3, 2.
So, no. Shh. Watch what we do. We drop this whole thing below the fraction bar. Remember how we do that?
7.
So we get 1 over 20. Oh gosh, not like that. 27. The exponent only becomes positive. Remember how we do that? We drop the whole power below, or if it's below, we move it above. Changes the sign of the exponent. Now from here, we can use the rules that we just learned. What's the index of the radical?
3.
Right?
9. I'm just kidding. 3.
So this is all happening now below the fraction bar because of that negative exponent.
So is it just going to be the whole equation just with 1 over it?
Yeah, right. Because like you just drop it below and it changes the sign of the exponent. So it makes it positive.
If the final answer is 9, it's just going to be 1 over 9?
Correct. Is the final answer 9?
Yeah, no, it's 3.
No, it's not. I was just...
I think it might be.
81.
No, it's 81.
It's 81. What's the cube root of 27?
9. It's 81.
No, what is the cube?
3.
What's the cube root of 27?
3. It's 9. It's
3. It's 3.
Yeah, but the answer is 9.
Yes. Ladies and gentlemen, the cube root of 27, which is what I was asking, is 3. And we then square that 3. So our final answer is 1 over 9.
That's right.
That's right.
That's a guess.
Okay. The first problem here is that we have what? The negative exponent. So let's draw a fraction bar. And we'll drop the entire power below the fraction bar. So this becomes 1 over 9 to the 5 halves. From here, now we can insert our radical and our exponents. So we get 1 over what? Tell me what the radical looks like.
1 over 243.
No. Tell me what the radical looks like.
It's 9 and the 2 and 5.
1 over the square root.
Of 9
To
to the 5th.
Yes.
And then you get 1 over 243.
1 over, yeah, so square root of 9 is 3 to the 5th, and thank goodness we did that already. 1 over 243. 3 to the 5th is 243. With your voices off, por favor. Remember, okay, here, remember this situation where we've got a quotient, right? We've got something inside our parentheses taken to an exponent. Remember, we give this exponent to both the numerator and the denominator. Do you remember this?
Yes. This is going to be an interesting problem then.
So watch what happens.
Wait, what?
They gave, you guys, stop. Are you with me so far?
Yeah. Yes.
We gave that exponent of 1/2 to our numerator and our denominator because that's what we do when we have a quotient taken to a power. Now, let's change our fractional exponent, the square root of 1 to the first, over the square root of 100 to the first. Are you with me? Do you see how we went from one to the other?
Yes.
The denominator becomes the index, and the numerator is the exponent. Can we simplify from here?
Yeah.
Okay, in the numerator, the square root of 1 is 1 to the first power is 1. On the bottom, the square root of 100 is 10 to the first power is 10.
What's so funny?
Okay, simplify this. Simplify this. Just do it the same way that we just did it. We should be giving this exponent to both the numerator and to the denominator. All right, what did we get in our numerator? 1 to the 1/3 over 8 to the 1/3. Right, exactly. You're way ahead of me. Cube root of 1 to the first power. So we take that fraction, change it into the index and the exponent. And on the bottom, we get the cube root of 8 to the first power. And then we simplify. Cube root of 1 is 1 to the first power is 1. Cube root of 8 is 2 to the first power is 2.
You get 1/2.
So it should be 1/2.
Yay! I did that.
Homework. Just be careful. Listen so that you don't get confused. On some of them, they're just going to ask you to rewrite and not to solve.
Wait, what? It's gonna ask you to solve it.
So all they want you to do is take this, make your base, remember your base is always the radicand, and take it to a fraction. What would your fraction be?
Negative or 1/24.
No, what would your fraction be? 2/3. Remember, this is your denominator.
Oh.
Yes, just rewrite it in a different format. You're not solving, you're just rewriting. Sometimes they'll ask you to rewrite it in radical form, but not solve, so they'll do something like this. Can you take that and write it as a radical?
Yes.
What is it?
It's 3.
Wait, is that 7?
17. So how would, yes.
17 to the 5th.
Yes, cube root of 17 to the 5th power. So can you solve this? No. We can't simplify this further. All it's asking you to do is just to rewrite it from the fraction to the radical, or vice versa, from the radical to the fraction. Thank you. Can you take it off of your head?